Hello, good evening, all.
Hi, ma'am.
Yeah, so today we have the open session for week 6. So I'll share my screen and see very few people have joined it. Okay, so can you tell me one by one, like, uh, what are the doubts that you want me to take from week 6?
Madam, AQ 6.1, question
Okay.
number 6, and question number 7, if it can be done by integration process.
Question number 6 and 7, okay.
And question number 7, ma'am, if you can kindly show us how to do it through integration.
Okay. Anything else? Okay, so let's, yeah.
About the marginal probability concept here actually.
How do you find the marginal?
Yes, ma'am. Actually, that the slice method what sir has used in that thing, so that's little unclear for me. I'm not able to
Okay.
apply that to
Yes,
the.
ma'am. Same here.
Okay. Okay. Anything else? So let's start with the AQ 6.1. Just give me a minute. I will just write the question. So EQ 6.1. Let's look at question number 6. So this question had you have XY uniformly distributed. Okay. XY was uniformly distributed over the region D, and D is given as 3x greater than y, where x lies between 0 and 1 and y is greater than 0. So first, let's try to plot the figure. Okay. So x should lie between 0 to 1. So if this is our x, this is our y, then x should lie between 0 to 1 and y should be greater than 0. So basically we have this reason here, and we want it to be 3x greater than y. Now 3x greater than y will become, wait, yeah. Okay, so 3x greater than y should be what reason?
The right hand part. The
The
triangle.
right hand part, right? So this is our reason D. Now, from here, can you tell me what should be the joint distribution of this reason D?
Now it's 2 by 3.
It's 2 by 3. Okay, so how do you find the joint distribution? It's so what is the area of this triangle? It is half into base into height is 3. So it is 3 by 2. And we know the joint distribution will be 1 upon mod of D. So this is going to be 2 by 3 for this reason D. Otherwise, it is 0. Now, the question number 6 said, question number 6 was, so what is the probability that x lies between y lies between 2y? So if we try to plot the figure here, so x greater than x lying between y to 2y, right? And this is our x equal, sorry, this is our x equal 3x equal y.
Ma'am, the area which is down the line, under the line, is that like 3x greater than y? I mean,
3x greater than y, right?
how to find, ma'am? Like how you concrete?
Okay, so how, okay, so first what you do is, like, you know, x lies between 0 to 1. So first I do x lying between 0 to 1. Okay. Now, y should be greater than 0. So it should be in the first quadrant, the line that you see here. So the area like this, mostly this reason I'm interested in. Okay. Now 3x should be greater than y. So for that, we will plot 3x equal y. Okay. So once you plot 3x equal y, now so this was our 3x equal y, and 3x should be greater than y. So the reason to the x side, to the x axis side, so that we take as 3x greater than y. If it would have been 3x less than y, then it would have been opposite. So in that case, you would say y is greater than 3x. So this in that case, you would have taken this reason
That
near
would
the
be
y.
an unbounded region, ma'am.
Sorry,
Would that have been an unbounded region?
unbounded reason. Yeah. Then your y, because y is greater than 0, right? So the limit of y will go from this 3x to infinity. But in this case, the 3x is greater than y. It means to the x side, we are saying this is greater. So any x you take, for that 3x becomes greater than y. So in general, whenever a situation like this happens, you shade the reason near to that axis, on that axis. Okay, so x lying between y to 2y. Now we first, so if we have to find this, so what we will do is we'll plot x equal y and we'll plot x equal to y. Okay. So let's see this, let's say this is our x equal y. This should be our one, and x equal to 2y. How will this graph look? X equal to y. So it should be something like this, right? So this is x equal to y. Okay. And this point should be 1 by 2. Right? Now what we want is that your x should be greater than this y. So this line is this line over here. I'll change the color. Hmm. Let's stick with this only.
That
Yeah.
this is going to be the area of the triangle minus that middle slice.
Okay. So let's decide on this. We want x to be greater than y. So this line over here, this line, okay, this is x equal y. So x should be greater than y. So what area should I shade? X greater than y. Let's just look at x greater than y. So what area should I shade?
That is triangle with 1 and 1 minus triangle with 1 and a half side.
No, I'm just asking for this x greater than y. So this line here is x equal y. Right? And I want to shade the region that is x is greater than y. So what region should I shade?
From the lower
Below
half
the
of
line
the-
x is equal to y.
below
Right?
the
So
line.
this whole thing, this triangle 0, 1, 1. Okay. This is 0, 1, 1, and this is 1, 0. So this triangle will shade. But now we want x to be less than 2y. So this line is x equal to 2y. So what should be x less than 2y? It should be above the this part, right? This whole thing. This whole thing intersect with this down. Okay. So this intersection, if you do, I should make some other figure. Wait, that's very. Just give me a minute. I'll start again. This is better. So x, y, we had x line between 0 to 1, y greater than 0. Then we had 3x to be greater than y. This is our 3. So we had this reason. So this was our D, and then we draw some other line. Oh. Let's see. This is x equal y, and this is x equal to y. So this is our common area that we want. Okay. So this reason over here is Okay. So this shaded region here is this x lies between y to 2y. Any doubt in this figure? Like if there is any doubt, I will explain again. Let's become messy. Like how did we get to this figure? Is there any doubt?
No, I'm clear.
Okay. So what we had to find is what is the probability? What is the probability that x lies between y to 2y? Okay. So basically this reason. Now to find the probability, we'll have to integrate this PDF, correct? So if we know the joint distribution and that came out to be 2 by 3. 2 by 3. So 2 by 3 dx dy. Now, let's say first I want to integrate with respect to x. Any idea on how we take the limit of integration?
Ma'am, may I say?
Yeah.
Ma'am, first I think we need to integrate for each we take an x, and for each x we have to integrate from we integrate the values of y from 0 to x by 2. And then once that integration is done, we have to integrate x from 0 to 1. That's how I think we should proceed.
Okay, so so you are saying if we want to integrate first with respect to y.
Yes, ma'am. We take an x value on the, say, on x axis, and for that x, if you draw a line, ma'am,
Okay.
between 0 to 1, a vertical line between 0 to 1.
Vertical line between 0 to 1, okay.
And for this particular line, as you can see, the value should be running from 0 to x by 2.
0 to x by 2. Okay, y is 0 to x by 2. Like you want this reason, right? You
Okay.
want the shaded reason. You want to find the probability for the shaded
My
reason.
bad then, ma'am. I think
So-
it should go from x by 2 to x.
X by 2 to x, right? Because if you draw a vertical line over here, so what is happening is like this line first touches the curve that is y equal x by 2, right? And y equal, the upper limit is y equal x. So if you want to integrate first with respect to x, so let's say I want, sorry, with respect to y. So let's say I want to integrate first with respect to y. So what we will do is so let's pull this out. So dy and y should vary from this x by 2 to x, and your x should vary from 0 to 1.
1.
Okay, so why x varying from 0 to 1?
Because ma'am, we
So
have
it
to
takes
take for
all the values from 0 to 1.
Sorry.
That's the range of x.
Because ma'am, you should take all the values from 0 to 1.
Yes.
That's
Okay.
the range of x.
So this is when we have to integrate first with respect to y. Okay. So if we do it, so what we will get? It is going to be 2 upon 3 integral 0 to 1. And if you integrate dy, it will be just y with lower limit to be x by 2 and upper limit to be x. Okay. And this is dx. So this will become x minus x by 2. Correct. So that is nothing but x by 2. Fine. I'll just write x by 2 here.
Yes, ma'am.
So this I will have to integrate over the region 0 to 1. Now if you do is, what is the integration of x by 2?
It's x square upon 2.
X
Square by
square
2.
upon 2, right? That is x dx. So x square
Uh-huh.
by 2.
Mm.
So this becomes, so 2 by 3. You can take this 2 out, and again you have x square by 2. So again you take 1, 2 out, and 0 to 1. If you solve this, you will get 1 upon 6.
6.
Right? So I hope this should be the answer. What is the answer for this question?
And so this is the probability or probability density.
Ma'am, the
Yes.
answer ranges between 0.15 to 0.18, so I guess it's good.
Okay.
And
So, yeah.
this is probability density or probability. I think this is probability, right?
This is probability, right?
Not density. Okay.
No. We had integrated the density and then got the probability.
Ma'am,
Huh?
please explain that drawing again. Can you come to drawing?
Yeah.
Yes. When we say x is less than 2y, right?
Yeah.
Why we are taking the upper range?
Okay.
Not the lower
So,
range?
okay, let's try it again. So if we say x is less than 2y, so this red line, this line,
That is x equal to 2y. That's clear.
that is x equal to y,
Yes,
and we
that is-
want 2y to be greater than x, correct? So it means this is the area, like this whole red shaded region.
No, why? So do we need to put some value and then check? Do we need to plug some value and then check?
Okay. So if you want to put some value, so let's take some, let's say take x equal 1/2.
Yes.
Okay.
Equal to 1/2, right? So my y will be 1/4.
This again became very messy.
So it's clear, man. Drawing
Okay.
is clear. Just explain why we are taking that, left hand side region, means upper region. And we are saying that x is less than 2y. So can we confirm it by putting some value by?
So what we just trying to say from here is, like, if you take any value there, any pair of xy, your 2y should be greater than x.
That's what I'm saying. Let us take x equal to half.
Okay.
X is half, then y will be, so y will be 1/4, right?
No, let's take any pair here. Let's
Yes.
take you're saying, let's say x equal half,
Yes.
and also take you're saying x equal 1, is it?
No, I'm saying x equal to 1. Half, sorry, half.
Okay, let's take both half of.
Okay, both half, okay.
So
So x is half, y is half, right?
yeah.
Yeah.
So this will be where? Somewhere this side.
The cursor is not visible.
Sorry.
Cursor is not visible. You are marking somewhere, you are marking something.
Oh yeah, wait. So x is 1/2
Right.
and y will be 1/2. Where? This is okay.
1/4.
Um, this is again 1. This is 1/2. Okay, so if you take any pair xy, so if we have taken x equal half and y equal half here, so is this graph correct? This will be 1/2, right? X equal, yeah, this will be 1/2, right? So if you take any point here,
Ma'am,
so
if
it will
I-
be somewhere in this region, correct?
If I consider equality, right? If I consider equality, x equal to 2y. So if I am taking x equal to half, then my y will be 1/4. Because why?
Then that will be this point. This point, right?
Ma'am, we lost track. What are we trying now?
No, what we are trying to do is like why we are shading this x greater than x is less than 2y, and x
Upper
less
part.
than 2y is the upper area, upper region.
Yeah, but can we not compare these three triangles and get the same 1.6?
These three
Top line is y.
3x equal
3x
y.
is 3x is greater than y.
This is
And
3x
x is
equal.
equal.
Yeah.
Yeah. So if you make a comparison of ratio of this shaded triangle to the 3x is greater than y triangle, it is same as 1/6, no?
No, this is not what we're trying to do.
Is it not the one what you're supposed to target at?
This one, the triangle.
The ratio of the shaded triangle and the bigger triangle. Is it not the one we should really take that as a graphical answer for the question what is asked?
No, I didn't get you what you're trying to say.
Okay, what is the question here is what is the probability of the shaded area? Is that right?
Yeah, right.
And what is the total area for that shaded area compared to be compared? Is it the bigger triangle?
PDF is not uniform, so we cannot take that.
No, PDF is uniform. PDF, it is given that it is uniform.
It is uniform.
But the answer is only the area of that shaded triangle.
Yes, yes.
Yes, right.
Area of the shaded triangle is easy to find it out. Is that?
No, this is not the question that he was asking. I mean, that probability calculation is clear.
Calculated. That is clear. I'm just asking that why the upper part is x is less than 2y, why not the lower part? I don't think that there is anything wrong in the question.
Sorry, Ganga Prasad, can you please speak a bit louder? I couldn't hear your question.
Hello, am I audible, Anirban, now?
Yeah. Please.
Yeah.
Yes. I'm just asking that when we are saying that x is less than 2y, then why we are considering the upper part, not the lower part? I'm not able to comprehend this, so I asked this question.
X is equal to 2y. X is less than 2y.
Yes, if x is less than 2y, then why it is the upper part, not the lower part of the x equal to 2y line?
The lower part will be x is greater than 2y, na?
That's fine. If that is the less than, then the lower part will be upper. Then why can we comprehend by computing? Can we comprehend by putting some value? Yes.
Yeah,
that
upper limit should be greater than lower limit. So y is greater than 2y.
No. As you just see here, x is less than 2y.
Yeah, Ganga Prasad, may I answer your question?
Yeah. Why not?
Like, ma'am, if it's possible to draw a unit square.
Yeah, I will draw.
Just a unit square, please, ma'am.
Okay. Can you say it here on the down?
Yes, ma'am. And let the top right be 1, 1.
Yeah.
Yeah, and ma'am, if you can kindly draw the diagonal as well.
Okay.
And now
What
this
x?
line is y equal to x. Right, ma'am?
Yeah, right.
So my question to Ganga Prasad would be now like to identify if x is greater than y, which area do you think should be the area? Like which triangle should be the upper one or the lower one?
Lower.
If you have to select the area where all points where x is greater than 2y, where do you think which area should you shade?
Can you explain by plugging some values? Because this is the same question, right? Like it was there x equal to 2y, now we are talking about x equal to y, right?
Yeah, exactly. So for x,
but the question remains the same. So can we understand this by plugging some values? That's my point. Can we understand this by plugging some values? Say, for example, we are taking a value for x and a value for y, and then we are understanding it. concretely.
Ma'am, may I say something? I'm sorry.
Yeah, yeah,
keep
yeah,
on,
please.
interrupting.
No, you play.
Yeah,
Yeah.
ma'am. What I'm trying to say here is that, ma'am, in the upper triangle, which we have just drawn, the values of x will always be less than values of y.
Values of x will always be less than values of y,
Rather, the
right?
y will
Yeah.
be greater than x.
Yeah, then y will be greater than x.
Similarly, ma'am, if we draw a line where x is equal to 2y,
Yeah.
and we want to find out for all the values of x which are less than 2y, it will be above that line.
Yeah.
Yes.
So does that answer the question?
Can you plug some value, ma'am? Can you take some value of x and y and you can prove it?
Ma'am, just take 1/2 and 3/4, for example. I think
Okay, for this case, let's take x equal 1/2, right?
yeah, 1/2 and 3/4. So we can
1/2
just plot
and
it where
3/4.
it is, plot where it is actually.
So okay, so this is x
3
equal
by 2 is the
1/2.
value of y or 2y?
This is x, this is y.
Okay. No,
Okay.
thinking.
Yeah. So x by, okay, this is 1/2 and 3/4 will be somewhere here. Okay. So 3/4. So if you plot this, it will come in this part.
In this case, x is less than y.
X is
yeah.
In this case, x is less than y. Yeah.
So if we take 3/4 and 1/2, you can clearly see that it's in the lower half of this line. Is it clear now?
Ganga Prasad, can we let's look at more examples after
Yes,
this,
ma'am. Let
and
us move ahead.
okay, and maybe it will be more clear later. So in this case, we had used the integration approach, but also since it was uniform, the distribution was uniform. So we can also use the triangle, the area of the triangle, and then so area of the region. So this region you are interested in, area of this region divided by the total region that you have. That also you can do.
Yeah, that's what I was asking for it. Now that gives 1/6.
Yeah.
So ma'am, like for the density function is not being uniform, we can't use the geometrical approach then, right?
Then you cannot use this approach. Yeah, right.
Then only we have to integrate. Okay.
You will have to integrate. So why I did the integration here? So you should also know like how do you do the integration, if the double integration mostly. So if you want to first integrate with respect to y, then you always try to plot a vertical line and then take the limit of y. You see what is the lower limit, what is the upper limit, and then accordingly you decide the limit for x. And if you want to integrate first with respect to x, then you will have to draw the horizontal line and then choose the limit for x. So this is something you should take care of when you do the integration.
Ma'am, can you please come again when to choose a vertical line or horizontal line?
Yeah, so when you want to integrate first with respect to y, then you plot the vertical line. But if you want to integrate first with respect to x, then you draw a horizontal line.
Oh, okay. So you got to decide whether it is dx dy or dy dx is based on the vertical line or horizontal line. Is that right?
No, it's not. It's your choice, I'm saying. Like in this case, first we had integrated with respect to y and then with respect to x. So since we were integrating first with respect to y, what we did is we drew a vertical line, right? We had drawn a vertical line and then decided our limit. But in case we had decided to do the integration first with respect to x, then we would have drawn the horizontal line. Please,
Okay.
yeah.
Okay. But the integral will be same, is it? 2 by 3 is same.
Yeah, integral will come out to be same, right?
But no, but that can't be like that, no, because
No, integral will come out to be same.
oh no, x is equal to 3y. That's the basis on which we put y is equal to 2 by 3x. Is that right? So when we change the dy dx, then it becomes 3 by 2. Is it? Am I right or wrong?
When we say,
Oh, we lost your screen.
yeah. So what were you saying?
Then we put an integral 2 by 3 dx dy. That's
Okay.
no, that's what it was already there in the no.
Yeah.
Okay. So this is based on y is greater than 3x. Is it?
This
That
is
was the
based on
line. How did we get the 2 by 3?
your voice is cutting in between. I couldn't listen properly.
How did we get 2 by 3, ma'am?
2 by 3 was the this function,
This
join
function
PDF,
y
join PDF.
join PDF y is greater than 3x. Is that right?
Yeah, it was 3x greater than y.
3x is greater than y.
Yeah. This is what we discussed at the beginning. So this was our 3x greater than 3x equal y. So
Yes.
this was our area. It was covered.
Okay.
So what is the area of this triangle? Half into base into height. So
Yeah.
half into base is 1. Height is, you can say, is 3. So this
3.
comes out to be 3 by 2. Now, if you have to find the joint density of xy, since it is uniformly distributed, we know that it comes 1 upon area of this
A.
region D, right? So it will come out to be 2 by 3.
Yeah, but now,
Yeah.
okay, it is dx dy, and after we after we passed a couple of steps, we said that whether we have to put a horizontal line there or a vertical line, it is our choice.
Yeah, it is our choice.
Our choice is to calculate the shaded area or to progress the calculation double integral.
No, the choice was, so we had x equal y and it's x equal to y. So this was the area we were interested in.
We are interested in. Yes.
Now we have to find the probability that your x lies between this region, correct?
The shaded area region.
Now to find the probability, we will have to integrate the joint density function, the joint PDF, right? The joint distribution.
Which means that integral what we already established.
Yeah. So how do you find the probability? Fxy, this is the joint distribution, and then you do dx dy, or you can do is double integral fxy xy dy dx. You can choose any one of it.
Okay, in any one of them, you said that integral
and what
value
I
of
said
2 by
is,
3 will same.
Yeah, integral value will come out to be same. This is what I have told.
Because the area is same, is it? Whichever way we take it, the area is same, so it will be there. Okay, I got it. Thank you.
Okay.
So if it is the uniform distribution, then we can just simply compare, ratio the areas, and we can take the answer.
Yeah. If it is uniform, you can just take the ratio mod of A divided by mod of T.
Why do we say mod? Area is always positive, no?
Yeah, I mean that representation was for the area. So
Okay.
I mean this representation here.
Right.
Madam, in case you are looking for more questions, I need help with formulation of seventh question in activity 6.1.
Seventh question in
Yes, ma'am. Even that was my question also.
Yeah, I always have trouble with modulus. So,
ma'am, if I may ask, like I could get the seventh question because the distribution, it's like XY is uniform. The joint distribution is given as uniform, right, ma'am? So we could like calculate it geometrically. So ma'am, now only thing is that let's say had it been given something like some constant k into xy or something like that, like how do we find out the density here? That was my question. My question is
so
like
question number 7 was xy is uniform in D, where D is your reason where mod of x plus mod of y is equal to 1, right? Less than equal to 1. Okay. So we had to find the joint distribution of this. First of all, we'll have to split it into various cases. So if x is positive, let's say if x is in the first quadrant, okay. If x is in the first quadrant, then both x and y will come out to be positive. So the first equation that you will get is x plus y is less than equal to 1. So first we'll plot this line, this curve, x plus y equal to 1, right? So x plus y equal to 1.
we start with the assumption saying x and y are positive, is it?
No, I will take all the cases.
Okay.
So
the
we
first
have,
case that we consider is x and y are positive.
yeah, first cases we consider is x greater than 0 and y greater than 0. Okay. Now, if x is, let's say, if x is less than 0 and y is greater than 0. So basically, you're looking for the second quadrant. Correct?
Yes, ma'am.
Yeah.
So if it is in second quadrant, your mod of x will open with minus x. Correct? Mod of x will open with minus x, right? Is that right?
Yes, ma'am.
And then
Yes, ma'am, correct.
since y is positive, your y will open with positive sign. And this should be less than equal to 1. Now, in here, what we want to draw is y minus x is equal to 1. Okay. So
yeah, here I have a question. Why do you say minus x when it is mod of x? Mod of x is always positive, isn't it?
yeah, mod of x is always positive, but how is the mod function defined? So how is this mod function defined? We say if x is greater than 0, okay, then it is x. But if x is less than 0, it is actually minus x.
Okay.
So, ma'am, overall, we'll have 4 cases here.
We will have 4 cases here, right? So, if you plot this curve, so one is done, this is done. Then the second that came out is y minus x equal to 1, right? So this, if you plot like this is your y minus x. Y minus x.
So I'll get a rhombus. No, actually it's a square. Only it is
No, you will get a rhombus.
Why a rhombus? Because it's all 1 1 1 1, isn't it? So I'll get a 0 1 1 0 1.
Yeah.
1,
So
0,
this is your
1 minus 0, 1.
This is 1, 0. This is your 1, 1.
0, 0, 1. Sorry, 0, 1.
Yeah, sorry. 0, 1. This is your what? This is
Minus
your
1, 0. Minus 1,
minus
0.
1, 0.
Minus 1, 0.
And then you will get
0 minus 1.
0 minus 1.
0 minus 1.
Okay. That's
Yeah.
fine. Yeah. Okay.
Now, so according to the first equation, your x plus y should be less than equal to 1. So this line is x plus y equal to 1, and you want this equation, this to be less than equal to 1. It means you want
Inside
this, right?
Yeah.
Then you want y minus x to be less than 1, right? So again inside this. So similarly, you will get these. So basically overall this area.
Yeah.
Now if you have to find the joint distribution, you can calculate, right?
Yeah. And this is basically, yeah. It will come as 2. So uniform distribution will be 1 by 2.
Ma'am.
Yeah.
Yes, tell me.
Thank you, ma'am. Very much.
Ma'am, here it's kind of easy. Like we can find out the effects by the limits they're given. I'm talking about, ma'am, what if had this not been uniform? How do we calculate the effects? Why?
If it was not uniform, how would okay.
And
That
where I'm coming from is
Yeah.
that, ma'am, I understand that if it's uniform, we can just calculate the area geometrically, right? To find the fxy, the joint density, we can calculate the joint density geometrically if it's a uniform distribution. But if it is not a uniform distribution and we want to find the joint density, how should we proceed? That is my question.
calculating, yeah.
They would give you PDF.
Sorry.
No?
I would like to ask about the answer once again. This is given as option 2. X comma y belongs to D and not A or C. Can you please explain why it is so?
Not is given as B, not
No. The answer is half for X comma y belongs to D.
okay.
The incorrect answers are for X lying between -1 to 1, Y lying between -1 to 1.
Okay.
And the other incorrect answer is X greater than 1, Y greater than 1. Probably that is okay. That I
So
think.
if you take X lying between -1 to 1 and Y lying between -1 to 1, that was option, right?
Yes.
Yeah. So what okay.
Ma'am,
X
that
lying
would be a
between
square, won't
-1
get the
to
wrong
1.
words.
Yeah. This is X lying between -1 to 1. Correct. I mean this cylinder, this space over here, and Y lying between -1 to 1 would be this.
Okay. All right.
It means this reason.
Yeah. Thank you. Sorry to have interrupted the other gentleman, please.
Yeah, somebody was asking if it was not uniform, how should we find the joint distribution function? Then in that case, this formula will not work and you will have to, it will be quite difficult to find it if it is not uniformly distributed.
Ma'am, as long as we don't get such questions of non-uniform distribution with mod functions, I'm cool.
Like you will not get such questions, but finding the joint distribution function, if it is not uniform, it is like we cannot say like how will you calculate the area. Like unless you know how this whole thing looks like in 3D picture, it's very difficult to find the actual joint density, like joint distribution. So we can have some GeoGebra illustration for that, like how in case of something that is not uniform, how does this look like?
Okay, ma'am, no problem. We can take it up later.
Yeah.
Then. Thank you.
Yeah. Okay. Okay.
Still, I'm not able to reconcile to the real answer now from this one. Real answer is
Yeah.
half for x, y, d, no? D
Half
is
for
the,
x. D is this
D is the
reason.
entire area, is it?
This reason, yeah, this reason is defined as D.
Yes. Then how is it half?
How is it half? Okay.
Half or between
So
and
you will have to find the area, right? So let's just take, you know, like all this 4 triangle are identical,
1/2.
almost, right? So
1
this
by
will come out to be what? Half into base into height.
Yeah,
Half
that's 1
into
by
base
2.
into height, that is 1/2.
Yeah.
Now it is 4 of them. So
4
into
of them,
4.
yes.
So it will come out to be 2. Now, since it is uniformly distributed, I will just say it is 1/2.
No, is it not that common quadrant we have to take it? Because what is the point of -1 to 1 for x and -1 to 1 for y? So only this
I didn't
bottom,
get, can you repeat? I didn't get you.
the limit is not putting a constraint, is it?
The length?
Limit.
The length limit.
How do you mean?
So if you
Okay.
have to find the joint distribution of 2 random variable, and if it is uniformly distributed, what do? You just do 1 upon whatever the area of this region is. So what is the area of this region that we found? It is 1. It is 2. So if you
2.
do 1/2, 1 by the area of this region, it comes out to be 1/2.
Right.
Right. So basically it is the joint distribution is just 1/2.
Right. But 0 otherwise, how do we really, I'm not able to follow that. 0 otherwise, what is that?
0 unless it is in this reason, I mean this D, it is going to be 1/2, otherwise it is 0. It is just a way to write the joint distribution, nothing else. So apart from this reason D, you will have the joint distribution to be 0.
If it is suppose -2, 0, -2, 0, and all the 4
-2.
corners are,
Yeah,
all
so
the 4 corners are instead of 1, it becomes 2.
What?
Can I take it like that? Otherwise, 0. So otherwise, what I am thinking that instead of 0, 1, all the ones in the present sketch is replaced with 2.
Okay.
Then it will be double, so 1/4, is it? So I'm not able to understand what is the otherwise means here.
So,
otherwise means outside the area of D.
Yeah, outside the area of D. So this is how your D was defined. Okay, this is how your D was defined, and we plotted this D. We know this is the reason. So unless your points are in this region, the distribution is going to be 1/2, and outside this region it's just 0.
Okay.
Density, the density is going to be 1/2, right?
Understood.
Yeah.
So if
Yeah,
it
so
is
anything outside
it is
this will
greater,
be 0.
Anything outside is going to be 0.
The probability of that being outside this point is 0. Is that it?
Yeah, right.
okay, the only possible outside is greater than 1, is it?
What?
In this equation, D equation, mod x plus mod y
If
is
you
less
make
than or
it
equal
greater
to
than
1.
1, it will be 0.
Yes, okay. Means outside the
Outside
shaded
this
area.
region D, yeah, the probability will come out to be 0.
Right, okay, thank you. Thank you.
Okay.
I have a question, ma'am, here.
Yeah. What was the other question? In this only?
Yes, ma'am.
Okay.
Why the first option is incorrect? Means
I just told like
yes, but these are the ranges now for for the region D, area D, X is between -1 and 1. And for region, same holds for region D also, na?
So if we say that X lies between -1 to 1, okay. If we just look at this, it means
Okay.
we are
Got it, ma'am.
looking
Got
at
it.
the reason.
Yes, got it,
You
ma'am.
got
Thank
it?
you.
Okay.
That question has still a valid doubt on that one, because between -1 to -1, still the four quarters of the sketch is valid only, no?
But there -1 to 1, there are outside four triangles which are blank that also are included, so they won't be counted.
-1 to 1 outside the four triangles areas are included. The white space. What you're telling is the white space is included.
That's why that becomes false. Option 1 becomes false because in option 1, outside the area of D, the four triangles outside the area of D are also included in option 1.
No, because your equation is less than or equal to 1, no?
Yes, but the range is, but the PDF is given such that X is -1 to 1, though.
No, so still outside will not be included, no? Because of the limit on the equation. Am I right or wrong?
Yes, I also thought that. That's why I asked the question.
Just take the point -1 and 1. You'll clearly see that it's outside this region.
Gordon, it's not. Can you please come again?
Yeah, if you take the point -1, 1, you can see that
Here.
it's outside the point, right?
Yes, but what we are trying to say that it is defined as mod X plus mod Y is equal to 1. So that point will anyway not be included.
Yes. Just below that, that's what it comes now.
But the condition on D is such that mod X plus mod Y is less than 1. So that point anyway will not be included when ranges are -1 to 1. That's what I thought.
But still, that's a valid basis what you're having. I don't see anything wrong.
Yes.
So get back to the original question, why it is wrong.
I can't think of anything now.
Ma'am, are we right in our question or not?
So the doubt is, since you're saying that this D is not included, so we cannot take this, right?
Yes.
Okay. So
by that way, the option 1 should also be correct.
Ma'am, can I just say
wait.
something?
Yeah. Yes.
It is given that the PDF, the PDF is given as 1/2, right? That means the entire area will will have uniform density of 1/2, right?
Yeah, right.
So by drawing the graph, we can clearly see that the area outside that square will be 0, right?
Yes, right.
So we cannot say that the entire area enclosed by -1 less than X less than 1 and -1 less than Y less than 1 can be uniformly distributed in 1/2, right?
Yes.
And that's enough proof.
That's what I got. Means in the PDF there is no condition on X plus mod Y is less than 1. In the PDF it's not the condition, so the entire region becomes valid for PDF, and that's why that answer will be incorrect.
Yeah, that's why the answer is incorrect, I think. Yeah.
Is it clear?
Yes, ma'am. Yes. Move ahead.
Okay.
Yes, ma'am. We can move ahead.
What was the next doubt? The marginal density, right?
Yes, ma'am. And on slicing.
Slicing part, right? The slicing will be more visible. Okay. Let's take the first example that is done in the lecture for marginal. So you have a unit square and xy is uniform in this unit square. So this is 1. This is 0. This is 1. Now, if I want to find the marginal of x, so what we do is we take our fxy and we integrate with respect to y. So we are fixing our x. I think the 3D picture would be better for this. Let's do this. Okay. Yeah, so basically what we are saying is we'll have 3 axes here. Let's make the other axis. So this is our unit square, okay. Let's assume this is our unit square. Now what we are doing is we are slicing, if we are saying we are slicing this, okay. So let's say we are slicing it, we are fixing an x. If this is our x-axis, this is our y-axis, and this is our z-axis. So if we are fixing some x, let's say we are fixing this x naught, and we are slicing this the whole area, the whole region. So how will you do this? It will be, you'll have something like this, right? You will get this sheet kind of thing that you're looking at here. So this is what we mean by slicing. So we have fixed a point like x, like if we're fixing, let's say x. So we have fixed a point x naught, and on this point x naught, we are trying to slice it. We have sliced this whole region. So this thin sheet that you see here, so it separates into two regions, right? Can you, are you able to see that this thin sheet over here that we have drawn?
At
Yeah.
x0, right?
Like, sorry,
At x0.
Yes.
I couldn't hear.
You're talking about the sheet that's
Slide.
at x0, right? X0.
Right, X
Okay.
naught. So is it the picture is clear, correct?
Yeah, that's clear.
Okay, picture is clear. So this is what we had meant by slicing the region. Now, if you want to do it for like, let's say you want to find fx of x. So to find the marginal of x, we know the joint distribution is fx of xy is 1 for x lying between 0 to 1 and y lying between 0 to 1. 0 otherwise. So if you want to find the marginal of x, what we are doing is you have to integrate fx of y with respect to other variable y. So your y is varying, but you have fixed your x. So if you can see over here is you have fixed your x, but your y is varying, right? I should have written this as y. No.
That would be fair.
Yeah, that. I don't know if I have the picture right now, the 3D picture. Okay, right. So you can see that your x is fixed, but your y is varying. This part. You have to take this whole y, correct? And this is varying from 0 to 1. I think it's difficult to visualize this in this picture. Can we do this one GeoGebra session for the visualization? Yeah, I think that will be better.
Yeah.
Yeah, drawing everything by hand is complicated. So yeah, so what we'll do is for let's do like today's session, just do the problem solving part. So in one of our session, we'll do some illustrations where we can see the non-uniform distribution and the slicing part. So how do we take the limit and all that in 3D we can see. So let's put it on hold for today's session. We'll do just the problem solving today. Is it okay? We'll schedule one session next week.
Yes, ma'am. Okay, ma'am.
Yeah, ma'am.
Okay, that will be better.
If
Okay,
we're
so
going to the next problem, are there any lined up or?
Sorry?
Yeah, are there any questions lined up or can I ask?
No, there is no problem. You can ask. Yeah.
6.2, question 3.
EQ 6.2, question number 3.
I realize it is a triangle. but when it comes to scheduling finding the marginal density,
Okay.
I am having trouble with this between, I'm assuming it as one of the two options between one and two. But where exactly is this coming? Because if I look at it, both of them are giving, one of them is giving negative probability. And
that is not possible.
okay. So perhaps that is the answer.
The probability can never be negative, right?
In an area, when the session was going on, there is a possibility of it being negative in a local area is what one of the statements I remember it as, but I'm not really sure. I could probably take your help in validating that. Is it never possible that at any particular instance of time during this function, the probability can be negative?
Probability is a function that is defined, like whose range is 0 to 1. Right?
So it can never be.
It can never be negative.
Okay.
So question number 3 was like you have a random variable xy that is continuous, and the joint PDF is given to it is 1/4 for x lying between y/2 to 0 and y 0 to 4.
Yeah.
Otherwise it is 0.
So I'm getting that as a triangle with 4 on the y-axis, 2 on the x-axis. The area is 4, so
it is not okay. You have to find the marginal, right?
Yeah, I'm just going from the very basics for every question.
Okay, so okay.
I get familiar
this
with
is
it.
x, this is y. Y lies between 0 to 4. Let's say this is our 4, and x lies between 0 to y/2.
It's 2 at max.
So x equal y/2 will draw. No. So we want your x to be greater than 0. So this side, and we want this to be less than x to be less than y/2.
Yeah.
So definitely not this reason. So what reason this will be? X greater than 0 and x should be less than y/2. So
upper region.
Upper region, right?
Oh, okay.
So this is your x equal y/2.
Yeah.
Now you have to find the marginal density of marginal density of y.
Yeah.
So if we have to find the marginal of y, so we'll have to integrate that with respect to x. Correct?
Yeah.
So marginal of y will become integral of fxy xy with respect to y. Now, how should we have to integrate with respect to y? So what should be the limit for this?
0 to 4.
Start from 0, man.
Y starts from 0. Okay.
Yeah.
You're saying y starts from 0, and what should the upper limit?
No, my
4.
y.
Sorry?
Y goes to 4.
Okay. So if you do this, what will you get? So fxy is 1/4. So 1/4 into 4, it will come out to be 1.
Yeah.
Yeah. So
Ma'am,
the
just
limit that you have taken. Yeah.
a small
Yeah.
doubt.
Okay.
I think we are finding marginal of y, right?
Yeah.
Should we be
We have
integrating?
to keep y constant and we have to integrate with respect to x.
Yes. Big mistake. Yeah. So we have to keep a fix y and integrate with respect to x. So yeah, can you tell me the limit for x?
Yeah, so x is 0. Start from 0 and then
it goes to
it will go up to y by
0
Y
2.
by 2.
y by 2.
Y by
Right?
2, yes.
So fy of y is x going from 0 to y by 2. It will be 1 by 4 of xy, and this is dx. So it becomes y by 8. And if you had to find
So now this is the density.
yeah, this is the
this is density or marginal
margin. This is a margin. You can say it marginal density, marginal probability. It is fine. Now, if you had to find the marginal density of we have to find for y, marginal density of x, then we will have to fix
Integrate
x
over
and
Y.
integrate with respect to y. Right? And in that case, the limit would have varied from y by 2 to 4. Y by 2 to 4.
Why y by 2, madam?
Why? What?
Why is it y by 2 to 4?
Okay, so
because-
fx of x, integral fxy, xy, dy, right?
dy, yeah.
So how is the y varying? Y is varying from this curve, right? What is this curve? This is, sorry, not y by 2. It is 2x.
2y.
2x. So it is varying from this 2x, this curve, to this point, that is 4.
2x to 4.
Yeah.
Which point, madam? Okay, to 4. Okay.
I mean, this curve to 4. This is how your y is varying. Maximum, we know that it can go till 4, but minimum is 0. But we have to look for this curve. This is going on this curve. Y is varying on this curve.
Right.
And this curve is y equal 2x. So the lower limit should be 2x, and this upper limit is 4.
4. Okay. So I'll end up with 4 minus 2x, is it?
So it will be 4. 1 by 4. Y should vary from 2x to 4. So 4 minus 2x by 4.
1 minus x by 2.
Yeah.
Interesting. So if the triangle were to be on the bottom half,
okay,
would that change anything? Because the area wise, it should not change anything, isn't it?
Okay, so if
then
the
we'll
triangle,
be integrating from 0 to 2x, right?
yes, integration will change the limit. So if it was a marginal density of x, then your y is varying from 0 to this 2x.
Okay.
Because the lower limit is fixed, that is 0, and maximum it can go till this curve. So that is 2x.
Okay.
Ma'am, I have a doubt on this y by 8. How did you get that? Integral
y by
1 by
8.
4, 1 by 4 dx. The limit, the next one, just above.
Okay.
Just above.
There, right?
Marginal y is equal to integral x is equal to 0 to y by 4. Is that right?
Y by 2.
Y
right?
by 2. Y by 2. Why y by 4?
2.
This curve is x varying from 0 to y by 2.
Okay. Okay. So y by 2. Then why are we doing on x? You are trying to find out
Marginal density of x. Yeah.
X. Okay, which is not asked for it, but for completion you are doing that.
Yeah.
Right?
Yeah. Right. Yes.
Area is a below part, then the way we discuss for y. So similarly, the integers of y, limit of x will vary from 0 to 2. In that case,
What?
In that case, limit of x will vary from 0 to 2. If we are talking
No.
about the
What
lower
was your what
lower triangle?
has
If we are talking
0
about,
to?
in that case,
You are talking about marginal density of
yes,
x or
yes. Marginal
okay, marginal density of x. Okay, so can you tell me what should be the limit for y?
For x, y will vary. No? Will integrate over y, right?
So how should the limit should vary?
Let me discuss that 0 to 2y.
0 to 2y. Y to y? 0 to 2x, right?
Sorry, 0 to 2x, right? What in other case? What in other case?
What in other case, Hasan?
Like 0 to 2x is the limit of y, right?
Okay, let's do this again.
For marginal of x and marginal of y.
Okay, I'll ask you. Now this is now we are talking about this red shaded region. Lower part. So this is fy of y. Okay, and you have to do fxy xy dx. So how is the limit of x going to vary? So what should be the lower limit? Can you tell me?
For x,
Yeah,
for 0.
Okay, you're saying lower limit should be 0, and what should be the upper limit?
Then it should be y by 2.
Y by 2, upper limit.
Yes, I'm just asking. I'm also not sure. That's what I'm asking.
No.
Y by 2.
Okay, so you are saying the lower limit. This is for the red shaded region.
Yes.
The lower limit should be 0, and upper limit should be y by 2. Okay, so I would ask. So why did you answer this? Like why the upper limit?
Yes, I answered this because when my x is becoming 2, correct? When x is becoming 2, the value of y is, sorry, the value of y becomes 2x.
If x is 2, value of y becomes 4.
Yes, 2x. Yes, 4, right? So here I am putting the limit in terms of y, right? While integrating x, I am putting limit in terms of y, right?
Okay, so we are fixing our x. We are fixing our y and integrating with respect to x. Okay, so how, if you have to integrate with respect to x, you just draw a horizontal line. Okay. So how is this horizontal line touching this region, a red shaded region? So the first is this point. So how is this point defined? This is going to be
x by 2. Sorry.
Y by 2. It means for some. This is
x. For some x.
Yeah, for some x, this is 5 by 2. And this is what? X is? What is this point? X is
2.
X is 2. So it should be not, lower limit should not be 0. It should be y by 2. And the upper limit should be 2.
Okay.
And the for x we have already discussed.
Now lower limit should be x by 2 or y by 2?
You tell me what should be the lower limit.
We are trying to integrate over y, right?
We are trying to integrate over x. We are fixing y and integrating with respect to x, right? So if you
Yes,
are
right. For a particular value of y, we are seeing the values that are running from.
Yes.
Okay, got it. Got it. Thank you.
Okay. Anything else?
If there is no question from week 6, then may I ask something from week 5, ma'am?
Something from week 5.
Yes. Not a question, ma'am. Just help me to understand
so
how to just help me to understand how to calculate variance of a function. Like while calculating expected value of a function, we use the formula gx fx of x dx, right? You can write it down also. Like expected value of function is
yeah, I got your point. Wait.
Yeah, gx fx of x dx, right?
Yeah, right.
So while calculating the variance of function of the same function, then what should we do? How should I approach? Not we, because I am having this problem.
So your doubt is how do you find the variance of x if
function
function of a ramp if variance of fx?
X is clear because for x we also integrate with respect to x square, like x square fx of x dx, and then we subtract expected value of x square minus e of x whole square, right? That is clear.
So
function.
If we have to find variance of
function,
variance of x, what do we do?
For variance of x, okay, we calculate expected value of x, and we also calculate expected value of x square.
So this is expected value of x square minus expected value of x whole square, right?
Yes.
Now, can you tell me what is your fx?
My fx is, for example, there are two variables, so I can take y equal to xz plus x.
What? Tell me.
There are two variables, x and z, correct?
Okay.
And they are related to each other with the function y equal to xz plus x.
This is three variable, y equal x plus x
Y
plus.
equal to xz plus x.
Okay.
Yes, if I have to find out the variance of this function, I have to find variance of this function, then how should I approach it?
Okay, first of all, it is the function of you have three random variables here you have written.
Yeah, so originally there are two variables, x and z, right? And they are related to each other through this function. So
yeah, but
is it possible to find out the variance of this kind of function?
Okay, so you are saying y equal xz plus x.
Yes.
So we can find, but we'll have to find what is the joint distribution. Now you have three different random variables here. Or let's say two different random variable xz plus x, and we have defined another random variable that is xz plus x. So are you trying to find variance of y?
Yes, ma'am.
Okay. So variance of xz plus x. Okay. So how you will proceed further?
As a layman, I will say that I will find out the variance of xz plus variance of x. But I don't know whether that expression is correct or not. I don't know whether that expression is correct or not.
No, okay. So why will you find variance of xz and variance of x? Like what will you get after this?
I will get.
You will not get after finding these two. You cannot sum these two and get this.
Yes.
Yeah. So why will you find this? It is finding these two. Like it's not going to solve this problem.
No, if variables are independent, then this may solve the problem.
Okay. let's say like which all variables are independent here?
X and Z are independent.
Okay, let's say X and Z are independent. Okay. So X and Z are independent, but is XZ and X independent? Do we know this?
Pardon me? There was some
Is XZ and X independent? We know X and Z are independent.
Can't say.
Okay?
Can't say this.
We cannot say, right?
Yes.
So we cannot do this.
Okay. Then what should be our question?
May I interrupt?
Sorry.
I think this was a question in graded assignment 5. It was in question 2 for my set.
Question number.
Anirban?
Yeah, I think are you
Okay.
asking that question, that graded assignment question?
Anirban, the function is the same from the
But
graded assignment.
there it is not.
Yes, yes, I'm
Find the
coming to
variance
that.
of.
Yes, there it was not the finding the variance of that function.
Yeah.
That was something else. So I'm just asking. That's why I said, can we calculate? Say for example, if we come across a question like this that find the variance of this kind of function, is it possible or not?
No, you should have enough information. Like
Okay.
You just said you have this function defined over here,
Yes.
and
Yes,
X and Z are independent. We assumed it, and then you're trying to find the variance of XZ and X. But to use this property, that variance of one random variable plus another random variable is going to be sum of those two individual variances, is not unless so that was not possible.
permitted. Is not permitted.
Yeah, because we don't know here that we know only X and Z are independent, but is XZ and X independent? We don't know it. Okay, so this we cannot use it here. So we have like in case XZ and X are not like two random variables, let's say X and Y are not independent. If X and Y are not independent, then we have something, some formula from that also involves covariance. So I don't know what the formula is. I don't remember it completely, but it involves the covariance. So you can check it out, the formula on Google. Variance of X plus Y. Okay, so.
And if it could have been only two things, for example, Y equal to
Okay, so if
50,
in general,
50, yeah, 15x plus something, then
in general, variance of X plus Y is variance of X plus variance of Y plus 2 times covariance of XY. So only if those two random variables were independent, then we could say like in case XY were independent, then we know covariance will come out to be 0. So it just becomes variance of X plus variance of Y. Now, if we don't know that two random variables are independent, then we have something for some formula with covariance involved. So if we want to use it, you will have to find what is the variance of XZ plus variance of X plus 2 times covariance of XZ comma X. It will be very complicated.
no, I'm asking that. I was asking if it could have been a simple one, like Y equal to 10x plus 5 or 15x plus 5, then how would you proceed?
Y equal 10x?
50, yeah, 10x plus 7. Anything, yeah, 10x plus something. Then how do you calculate variance of this function?
Okay, so you're saying if it was something called variance, simple like this, then would have like if it was easier.
Yeah, can we directly say it is 100 variances of Y is 100 times variance of X?
Sorry, yeah, we can directly say because you know the property of variance, right? So 10x plus 7, and you can pull it out. So it will become what? A square. A square is 100 times variance of X.
Okay, and then I will have to calculate expected value of X and expected value of X square.
Yes,
right?
yes.
So for expected value of X square, I will use that formula, X square fx of X dx, right? For x square, in order to calculate expected value of x square, I will be using the formula integration of x square.
Okay, yeah, right. X square, whatever your
fx of x.
Okay, you have fx of x dx. Yeah, right.
Okay, so that should be our approach.
Yeah.
Okay. Fine, thank you.
Yeah, okay.
Madam, we can go back to 6.2, question 5.
6.2, question 5.
I got the answer, but somehow I'm not convinced about the constants because I got it as 1/2. Here it is 2. And the x minus 1 and 1 minus y came out correct. So I picked the right option, but I got 1/2. I don't know where I made a mistake. Integration limits is what probably I am.
Question number 5, right?
Question 5, yeah.
Okay. So the reason D here is this is AQ 6.2, question number 5. So x minus 5 less greater than equal to 1, x lying between 1 to 2, and y is greater than 0.
Mm-hmm.
5 greater than 0 and x lying between 1 to 2. So this is 1, this is 2. And x minus y equal to 1. So x minus y equal to 1. So how will this line looks like?
It goes from y
You put
x1 to y. Sorry, when x is equal to 1, then it is
y 0.
1 comma 0. 1 comma 0 is 1 point, and 2 comma 1 is the next one.
Sort of y-intercept is 1 and it is x equal to y.
Sorry?
It's minus 1, isn't it? Y-intercept, isn't it minus 1?
Where is minus 1 coming from?
No, sorry. I think the gentleman is talking about y-intercept. Y-intercept would be minus 1 here, I think.
No.
Oh, y-intercept. Okay.
Yeah, y-intercept is 1. And from 1, it is x is equal to y, straight line, is it?
Okay, so instead of drawing these line first, so instead of drawing all this first, we'll draw. Okay. So x minus y equal to 1. This is what we want.
Yeah, x minus y equal to 1. So
it will go something like this.
Correct. Y-intercept will be minus 1 is what I said. So 1 comma 0 and 2 comma 1 seem to be good candidates.
And we want x minus y to be greater than equal to 1. So this is this curve is x minus y equal to 1, and you want x minus y to be greater than equal to 1. So which side it should go?
It will be bottom side.
Upside.
Which area should I shade here? If the condition is x lying between 1 to 2, y greater than 0.
The triangle.
Which triangle? Which triangle?
X between 1 and 2.
Yes, right?
Yeah.
This one. Now, okay. So what is the problem that statement? We have to find fx and we have to find fy.
Correct.
Right. So what is fx? So how do you find fx?
It's basically
so first of all, what is fxy?
Area is half. Area is half.
Okay. So area comes out to be half into base into 1. So
Oh,
area
it is.
so
Yeah, area.
this will become
It's
2. fx5 will become 2.
Yeah, that was my first mistake.
So 2 times dy. Sorry, 2 of 2 and dy. Now you are integrating like y with respect to, so you have to take the limit of y. So what should be the limit of y? So if we have to take the limit of y, what I had said is you take a vertical line and just see how is the y varying. So the lower limit should be y equal 0.
Right.
Right. So y equals 0. And what should be the upper limit?
That I think now it is clear. It is x minus 1.
It is x minus 1, right?
Yeah. Yeah.
Similarly, fy of y, it is 2 times dx. And if you have to do this, so what should be the lower limit?
Lower limit will be
now we have to integrate with respect to x, right?
X. Yeah.
So we drew a horizontal line. So how this horizontal line is intersecting this region? So what is the lower limit?
Lower limit is actually 1.
X minus 1.
So, okay, let's remove this line for now. So we drew a horizontal line, okay? Now, this line can shift anywhere, like it can be here, anywhere. Right? So it is on this line, on this curve.
Yeah.
So what is x going to be? It is going to be 1 plus y.
1 plus y.
And we know the x can go maximum till 2. Right? So the upper limit is 2.
But it is a horizontal line that is going right now.
Yeah.
So the value that is changing is only y, isn't it? Or am I making a mistake in understanding?
You have to see, if you have to find the marginal of y, it means you're fixing y, and you're varying your x. So you are varying your x, right? If you have drawn a horizontal line, you're varying your x, but your y is fixed.
Yeah.
Correct. So how is this x varying? This x is varying from, like, the lower limit will be on this
plus y.
curve, right? It is varying from this curve and it can go maximum till 2.
Yeah.
Right. So from 1 plus y to 2. So this is how we have taken the limit. X cannot go beyond 2.
Is it not that the limit for x is from 1 to 2?
No, it is not from 1 to 2.
Why?
So if you take the limit from 1 to 2, it means you're talking about this whole thing. I mean, this shaded region in black and this part, they are not involved, right? Like if you take the region from 1 to 2, right?
Yeah.
Then it also includes this region. If you do that, this also includes this region.
Oh, so.
But you want this limit to, like, this is your region of interest. This is your D. And you want to vary the limit. You want to see what is going to be the lower limit for this region D. So you can see that your x is varying. Like if you fix your y here, it will be this point, right? Your x is going to be varying from this point to this point. Now, if you fix your y here, then your x is varying from this point to this point, right?
Yeah.
Right.
So if it is 1.5, how do you
No, forget about any point here. So what I'm saying is, Wait, I'll plot this again here.
While fixing the limit for x, how the horizontal lines are
Wait.
limiting that?
Wait. So this was our graph 1, 2. This is 1, this is 0. This was our region D.
Yes.
Right? And what we want to do is we want to integrate, we want to vary our x, right? So we are fixing y. Okay. So
Yeah.
this was our y, and let's say I'm fixing this point. So if you fix this point, how is this y varying? So your y is varying from, sorry, how is your x varying? It is varying from this point to 2. X can go max. X is going from this point to 2. Now if I fix, this is for this y. Now if, let's say if I'm fixing this y over here, okay, now if I'm fixing this y and I am drawing a horizontal line, now how is your x varying? It is varying from this point to 2 again, right? It is, your x is not varying from 1 to 2, right? It is not coming from 1 to 2. It is coming from this point to 2. And what is this point? Since this graph was x minus y equal to 1. So this graph was x minus y equal to 1. So what is this point x? So this point x is going to be 1 plus y for some y. Right? So this is how we are taking the limit.
Okay.
Same thing we are doing for
the y-axis.
Yeah, for the y-axis.
So, okay, I have another question which might be very silly. 1 plus y, why is it a lower limit on?
Okay. Y 1 plus y is the lower limit. Okay, so this is what I was explaining, right? This part only. Yeah. So same thing, we are fixing y, we have fixed, let's say this is some y, we are fixing this. And if we are drawing a horizontal line, how is this, how is the x varying? X is varying from, x is varying from 1 plus y to 2. What is this point here? This point is 1 plus y, right?
Yeah.
So 1 plus y to 2.
Got it.
Or yeah, to see you can also take different, let's say y0, y1, y2, and accordingly it will vary. So you will not say that your limit is varying from 1 to 2. It is varying from 1 plus some y, whatever y you have fixed, to 2.
Yeah.
Is it always that the lower limit for y, the lower limit for x is derived from the equation, and the upper limit for the y is also derived from the... No.
So to check, you always do this, whatever I have done right now. So like if you take some different graph, let's take this graph. So in this case, let's find fy. So if you find fy, what you will do is, okay, forget about these lines here.
It's a dx or fx dx.
Let's just assume you don't have this. Okay, let's say this black part you have. Okay. And this was something. Okay, now it will be fxy xy. If you have to find the marginal of y, you will do dx. So to find the limit of x, so what you're going to do now, since you have to, you will do horizontal line. Okay, let's do horizontal line. So let's fix some y here. Let's say this is y0. Okay, so okay, this turned out to be the same example. Let's do it the other way.
It also comes with the same
Yeah, it's the
basis
same.
of fixing the limit. Yeah.
Yeah, right. So let's do it this way. Okay, let's take another example. Now take this. Suppose we want to find fx, fy. Okay. So this is going to be, and this is your x plus y equal to 1. All right. So you will integrate fxy xy dx. Correct. So
Yeah.
you want to vary x. So you will fix your y. Okay. So let's say I'm fixing this y, that is, let's say y naught. I'm drawing a horizontal line. And how is your x varying? So what should be the lower limit here? What is
0.
the 0? Okay. Now what should be the upper limit? What is this point?
1 minus y.
This is 1 minus y. So if you, this is basically 1 minus y naught because I fixed y naught. Okay. This is 1 minus y naught because I had fixed y naught. Okay. Now let's fix some other y1. If you fix this y1, again, what is the lower limit?
1 and 1 minus
Sorry?
y. Lower
Lower limit is
0.
staying as 0 and upper limit is going as 1 minus y1, right? So in whatever y you fix, so in general, if I'm fixing any y, so the lower limit is going to be same, that is 0. And the upper limit will come out to be 1 minus y.
Okay, this is to answer my question that always the lower limit is derived from the equation. So you are telling that it is not necessary. It will come otherwise also.
No, to check, like forget whether it is derived from equation or not, because you also have the equation that what is this? This is, what is this line? This line is x equals 0.
Yes.
Right. So this equation is x equals 0 and this is x plus y equal to 1. So it is true that you are going to derive it from equations, but how are you going to do it? That is more important.
Understood. Right. Thank you.
Yeah.
Thank you.
Madam, with the other triangle, that is the one where it is mirrored on the x-axis, it is a little counterintuitive to me. I'm trying to follow the same logic that you mentioned here.
Which one?
This earlier problem.
This one. Okay.
Yeah. So here, when we're talking about the value of y,
okay,
it is starting at 0, isn't it? It is 0 and then it is going till y is. Let's say I draw a vertical line.
Okay, so now you're talking about marginal density of y.
Yeah.
Sorry, marginal density of x.
X, correct. Yeah.
So fx of x.
Yeah.
Okay. Now this is going to be fxy xy dy.
Dy.
Right?
Yeah.
So if I want to now in this case, what you will have to do? You will have to fix your x and vary your y. Correct?
I have to fix my x and vary the y. Yes.
Yeah. So now I'm fixing my x. So let's say I'm fixing, let's say this x naught.
Yeah.
And we have to vary y. So how is this y varying? For this x naught, how is the y varying?
0 to the point on the line, which is
this point, right?
Yeah.
So what is this
Minus
point?
1.
This point is going to be 1
X
minus
1. Yeah. Okay.
Yeah.
Yeah.
Yeah. Yeah.
1 plus. Sorry, y equal
x minus 1.
X minus 1, right?
Yeah.
So x naught minus 1.
Correct? Yeah.
Now, if you fix some x1, again it is going to be what? The lower limit is again 0, but this upper limit is going to be 1, sorry, x1 minus 1, right?
Yeah.
So in general, any x you fix. So the lower limit is going to be 0 and the upper limit is going to be x minus 1.
Okay. And when we do the horizontal line for the same thing, then it is y naught, isn't it? Y naught that I'm actually referring to. It is going upwards and downwards. Now the line is moving left and right. When I go for the fy, it is going to be a horizontal line which is moving up and down.
So how you can just remember it as like if you have to find the marginal of x, okay, it means you are going to integrate with respect to y. You have to vary your y.
Right.
Right. So when you want to vary your y, you will have to make a vertical line.
When I want to vary the y, I need to make a vertical line. Yes.
Yeah. And if you want to if you have to find the marginal of y, then you will integrate with respect to x. It means you want to vary your x. And since x is in a horizontal axis, you are going to make a horizontal line. This is how you can remember.
Yeah. Okay.
Okay.
That part is clear. Now coming to the limits. Earlier we set it as 1 minus y because we are count. Okay.
Just make a clean figure and just try to.
No. Got it. Okay. The lower limit being we are still going for the direction of the x-axis, so it is 1 plus y till 2. Okay, got it. Got it, madam. Thank you. Thank you.
Okay. Okay. Anything else you want to clear? Should we close the session for today? It is 10. We can have, yeah, tell me.
No. You were mentioning something about next session, right? That's what I was.
Yeah. So yeah, we can have one more session where we can see how the slicing will look and how does this non-uniform distribution looks. So all this just things we can have a.
Correct. But that will be possible only tomorrow, no, madam. Between now and Tuesday, there is again another set of classes.
Tuesday is now, but solve with us. So in solve with us, if we can do the first like half an hour, 1 hour, will it be okay?
No, that is the most crucial one, madam.
Okay, so okay.
If it is possible tomorrow, else.
So okay, we'll schedule it tomorrow only then.
Thank you.
Yeah, okay.
And ma'am, humble request, if the YouTube link will also be visible, rather available for that this session on tomorrow, that would be great.
Okay, yeah. All right. Yeah, so let's close the session for today and we'll meet.
Yeah, just a general question.
Yeah.
The quiz
one more question can I ask?
Okay.
Tutorial 1.
Tutorial 1.
Yeah. Question number 1, find the value of k.
Okay, how do you find the value of k? Like.
Yeah, it's down.
So you know the okay. One hint I can give here is like, what the properties that it follows the joint distribution.
The probability.
The solution. Yeah, over the whole range or the whole domain, it should be equal to 1, right?
Yes.
So you will just substitute, like so in this case, you will try to integrate this fxy over this whole range where x is varying from 0 to 2 and y is varying from 0 to 2, and you will just put it equal to 1 and then try to integrate. Nothing else is there.
Remember that the order of integration is okay in either way. Either
Order
X
of
first or
integration
Y
doesn't matter. Yeah, you take anything you want, doesn't matter.
doesn't matter. The result will be same.
Yeah, it will be same. You can try it out also.
Oh, okay.
You can take it as an exercise and try to check.
So you got to really make an equation of equal to 1, then solve for it. Okay.
Yeah.
Yeah.
So the hint is given already. So if you have doubt, you can check it there.
The hint is given. No hint is given.
Yeah, you go to check answer and you will get the solution for tutorials.
Oh, okay.
The
But
solution is.
you don't get a solution, you get an answer only.
No, you get the solution.
Huh.
For tutorials, you get the detailed solution.
Detailed working solution, I'll get it.
Yeah.
Okay. Thank you.
Yeah.
Don't get me wrong when I ask this question, but what is the highest percentage that was the outcome from quiz 1?
Highest percentage?
Yeah.
Of
quiz
I
1
didn't get
in statistics.
like what I mean the result you're asking?
No. Not yeah. The result basically, what are the highest marks scored by the any of the students is what I was asking actually.
Oh, I have no idea yet.
Okay. Somebody had already written in the chat. It's 100%. So yeah, I wanted to rate myself and feel a little bad about it. Yeah.
Currently, it is like it is still under process. Oh.
Okay.
But